Part 2. Let's try to use our equations and solve the problem. Seems to be kind of hard to actually set up anything, because all we have, right, is, let's see here, when the car comes to a stop, well, we can say that's v of t equals 0. That's not so bad. What am I supposed to write down for the 500? Well, the 500 is actually the change in the position from the starting position to at that time. So we're actually going to have, right, for that specific time, that's the position at that specific time. This is the position at the very beginning. We're told that that is equal to 500. Now, this is not my favorite way to set up this problem, but it's very useful in physics, so now and then it's good to get in the habit. What is S of t? Well, S of t is just minus 1/2 kt squared plus 88t plus d. That's the position at the time the car comes to a stop, minus S of 0. Well, I'm looking up here. What is S of 0? That's just d, right? So the d's just cancel. And what we're told is that the change in the position is 500, like this. So I guess I'll try to write that cleaner down here and hope I don't run out of room. Minus 1/2 kt squared plus 88t equals 500. And what I'm going to do is just erase this little stuff in here so we have a little more room to work at. If you want to see what was there, you certainly can go do what you want. Now, when v of t equals 0, well, we have a formula for v of t. This is the same thing as saying minus kt plus 88 equals 0. That's the same thing as saying kt equals 88. And if I just wanted to do this in a straightforward fashion, I could solve this for k and plug into here. But I want to be as lazy as I possibly can. So this is what I'm going to do. I'm going to notice that kt goes into this bottom thing right here. So I'm going to, down here, I'm going to write this as minus 1/2 times kt times t plus 88t equals 500. And from here, I'm going to go back up and start writing right there. So I'm going to get minus 1/2 times kt, which is 88, times t, plus 88t equals 500. And now we see the arithmetic is going to be pretty easy, because minus 1/2 88t plus 1 times 88t is 1/2 88t. That's just 44t. So we're going to get 44t equals 500. Right? And so t is equal to 500 44ths. Like that. Now that's the time it comes to a stop. That's not k. We actually want how fast is it decelerating. So I'm going to plug back into our equation up there where it says kt equals 188. So I'm going to go k times t equals 88, like that. And so I'm going to get 44 times 88 over 500. I am going to let my calculator do this. Let's see. I think it's going to be 7 point something, but I'm really going to let my calculator do this. This is going to be 44 times 88 divided by 500. And we get 7.744 exactly. So we get equals 7.744 exactly. And that would be what? Feet per second squared. Feet per second squared. Anyways, that is the deceleration. Well, that's the acceleration. The actual deceleration would be negative that. Anyways, that's how we do it. You can see that being a little bit creative with our algebra is a better thing here than actually going straight forward through it.